Hello, everyone. Today we are working on Chapter 1, Lesson 3, Acceleration. It's the last reading we've got for this unit in the book before we've got our next test. Now, when I went to make this video, I'm like, should I make one? Shouldn't I make one? I was like, you know what? Maybe this might be the last one that I make, at least to get you guys started, because now this is our fourth one that we've done. We probably know how to do this, but just for a few people if they're still needing some help. So first thing, please put your name, please put when this is due, and then the hour you have science. Now I told you that this is Chapter 1, Lesson 3, Acceleration. So you can add that up to the top. And then you're going to need to log into your online textbook. So if you need to pause this video to do that, please do that. So now that you're joining with me, you are heading into your ebook. Now, I am making this video ahead of time, so it doesn't show that there's an assignment here, but likely there's going to be an assignment with like a little mini quiz on there, so I would go ahead and actually do that. So we need to then get to the right chapter and lesson. So in the upper left-hand corner, we can click on Contents and go Describing Motion, that drop down, and then Lesson 3, Acceleration. And I always double check to make sure I spelled acceleration right, because sometimes I'm a little off. The next thing is the vocab is what comes first. For this one, there's only one vocab word, and it's acceleration. So write that at the top. The next thing we're going to do is preview the questions that are at the end. Oops, and I went one too far. There we go. So there's a total of 8 questions. You're going to be defining acceleration in your own words. Use the term acceleration in a sentence. Refer or call how a roller coaster can accelerate even when it's moving at a constant speed. So it might not have an exact roller coaster example, but there might be something very similar. So look back at that. A speed time graph is a speed time graph is a horizontal line with a y value of 4. What's describing that object's motion? So if that's a horizontal line at 4, what's happening? So remember, you're on a speed time graph. So speed actually changing if it remains at 4. Think about that. Number 5, organize information, copy and fill in the graphic organizer for the 4 types of speed time graphs. So those are kind of shown in the textbook, so you need to go back and get those. Critical thinking, evaluate a race car accelerates on a straight track from 0 to 100 kilometers per hour in 6 seconds. Another race car accelerates from 0 to 100 kilometers per hour in 5 seconds. Compare the velocities and accelerations of these cars at their races. And then there's 2 other math ones. After 2 seconds, Isabella was riding her bike at 3 seconds. After 5 seconds, she was moving at 5.4 meters per second. Notice they're saying 2 seconds and 5 seconds for number 7. Really only 3 seconds have passed of time. So that's what you're going to need for number 7. Number 8, after 3 seconds, Mohammed was running at 1.2 meters per second on a straight path. After 7 seconds, he was running at 2.0 meters per second. What's his acceleration? So again, notice they're saying 3 seconds to 7 seconds. So the number 8 is actually going to be talking about 4 total seconds. Now, what the heck? What is the formula? You don't even know how to get this started. So if you do go back to this page, let's at least kind of talk about this formula a tiny bit. So the big thing first is, so its acceleration is equal to the final velocity minus the initial velocity divided by the difference in time. So how number 7 and number 8, it said it was over, like it said 2 seconds to 5 seconds or 3 seconds to 7. So the change in time there is 3 versus 4. Like, let's even just set one up here. So this is the formula, and you might want to write this down. I then like to go and have my variables set up so I can kind of sift those in. So our first one was, we'll do number 7 here. After 2 seconds, Isabella was riding her bike at 3 meters per second. So that's our initial. So 3 meters per second. And her final was 5.4 meters per second. And this took place between 5 seconds and 2 seconds. So 2, 3, 4, 5, that tells me 3 seconds. So now when I tuck these all in, so this would be like number 7, I'd rewrite it and go acceleration is equal to 5.4 meters per second minus 3.0 meters per second, all divided by 3 seconds. So this is going to be what? 2.4 meters per second. And then you're going to need to throw that into a calculator, get your answer. And remember, acceleration is measured in meters per second squared because I got a second and a second. So you got two of them, so it's squaring it if you remember from math class. Once you get your answer, you can box that in. Acceleration is a vector quantity, so we really should even add, it looks like she was moving forward, so we should also add that direction. Okay, you got a little helper there. The last thing I'm going to remind you to do is remember your vocab packet. This is something you want to make sure you're getting done so that, hint, clue, hint, this is also something that is on paper only, just like our paper notes. Hint, clue, hint. Make sure this is done. And yes, it is for a grade, but also a hint, clue, hint, paper copy. Huh. Or you're recreating it on paper. Huh. Interesting how that works out. Please let me or your other science teacher, if you have Mrs. Carpolinia, know if you have any questions. Otherwise, have a great day, guys. Bye.